Hello, now we're going to do a little example with this. Assume that the heights of young women are normally distributed with a mean of 64.5 and a standard deviation of 2.5. If we measured a sample of 10 young women, what would be the mean and standard deviation of that? Well, the mean of our X-bar population would be the same as our mean, which is 64.5. Our standard deviation of our X-bar would be our standard deviation from the population, divided by the square root of 10 because there's 10 girls. So now if I did that, I would get 0.79 for standard deviation. So now our next problem says, what's the probability that the height of 10 women, that the mean of the height of 10 women is greater than 65.5? So that's the probability that our mean, which is our X bar, is greater than 65.5. Now we're going to take our, since this is normal, we can take our z-score of 65.5, subtract our mean, 64.5, over our standard deviation, which was 0.79. Alright, so that's the probability that our z-score is greater than 1 over 0.79. So that's 1.27, say 65. We can say a 7. And to do that, that's a normal CDF from there to infinity. It's going to give us about 10%. 1027, 103, something like that. So about 10% of the time, a group of 10 women will have a height greater than 65.5. But what is the probability that one woman would be greater than 65.5? So that would be the probability that just one, so that's not an X bar, that's just an X, is greater than 65.5. So now that's the probability that my z-score is greater than 65.5 minus 64.5 over a total of 2.5, because it's the standard deviation for the population. So now my z-score is going to be 1 over 2.5, which is 0.4. So the probability that we go from 0.4 to infinity, now it increases to 34%, 34.3445. So if we round it out to 3, there it is. So if you look at this, it's going to be pretty rare for 10 women to be greater than 65.5. But about 35% of the time, one person could be out there. So if you look at these distributions, if I have one observation, the normal distribution is pretty low and wide. And if I have the mean of 10 observations, it sucks in the standard deviation, so now the distribution is taller and thinner.